Greetings of the day, dear students. In this video, we are going to discuss about the comparison of common base, common emitter and common collector configurations. In the previous videos, we have seen in detail about its circuit diagram configurations and the derivations of alpha, the variable current amplification factor alpha, beta and gamma. And also we have seen the relationship between the alpha and beta and alpha and gamma, right? And we have seen their input and output characteristics. In this video, a final summary with respect to the comparison of common base, common emitter and common collector configuration will be handled. Clear? This is simply the summary, right? Now, in exam point of view, while attempting a question from this, while attempting the question on this topic, out of these 7 parameters are to be highlighted. These 7 parameters are to be compared among common base, common emitter and common collector configuration. Dear students, you have to memorize all these 7 points. It is you have to highlight the input resistance, output resistance, voltage gain, current gain, leakage current, output signal phase, and what are the applications. Right? If it is common base, the input resistance will be very low. The input resistance is very low and it will be about some 100 ohms. For common emitter also it is low. It is around some 750 ohms. But whereas for common collector configuration, the input resistance is very high. It will be around some 750 kilo ohms. Right? If you recollect our previous topics, if it is a common base, if a base is a common, right, emitter, collector. In common emitter configuration, emitter is common to both the input and output and base, and this is the collector. Here you are having the input across the emitter and base, you are having the input, and across collector and base you are having the output. Here across emitter and base we are having the input, and across collector and emitter we are having the output. Similarly, this is common base, common emitter. And if it is a collector, base, this is common base configuration, this is common emitter configuration. Of course, not in detail I have drawn, already we have seen the circuit diagrams in the previous discussions, right? But the key point is, in common base, input will be across emitter and base, output will be across collector and base. In common emitter, input is across emitter and base, right? The output is across collector and emitter. In common collector, the input is across, this is the across here, this is the input we have applied, and the output is across emitter and collector, right? So now the output resistance in common base configuration, that means across this collector and base, it is very high. Collector and base is very high. That is the reason why in common collector the resistance is across where emitter and base, but that is acting here as input. That is the reason why input resistance for common collector is very high. You can observe here, right? Now the output resistance in common base configuration will be very high, and across common emitter configuration also it is high, right? And for common collector configuration, the output resistance is very low. the common collector configuration, the output resistance is low. It is only just some 50 ohms. Right? Now voltage gain, voltage amplification. If it is common base, the voltage gain, how do you define that? The gain, anything gain, related to gain, we will something related to output divided by input. If it is voltage, output voltage by input voltage. If it is current, output current by input current. So the voltage gain is about 150. How do you understand that? The output voltage will be 150 times, about 150 times the input voltage, if it is common base configuration. Here in common emitter, the output voltage will be about 500 times the input voltage. If input voltage is simply 1 volt, the output voltage will be around about 500 volts. That much amplification you can observe, that much gain in voltage we can observe if it is a common emitter. But if it is common base, if you give 1 volt as an input, you can get an output of about 150 volts. But if it is common collector, if you give some 1 volt as an input, you may get a value less than 1 volt. You may get an output voltage which is less than 1 volt. So it is, the gain is very less than unity. The value is less than unity. So the voltage gain is about 150 if it is common base. If it is common collector, about 500, and in common emitter, about 500. Common collector, it will be less than unity. So the gain, output value by input value, right? Here it is the voltage gain, so output voltage by input voltage. Similarly, current gain, in common base the value is less than 1. In common emitter mode, the output current, the gain is high, the output current will be more. But in common collector, it is just simply appreciable value. It's just simply an appreciable value, right? Leakage current, in common base it is very small. The leakage current will be just in the order of microamperes only. If it is of germanium made, and if it is of silicon, it is will be around some 1 microampere for silicon leakage current. And in common emitter mode, the leakage current is very large. It is around some 500 microamperes for germanium and some 20 microamperes for silicon. And in common collector mode also, the leakage current is very large. In common collector mode also, the leakage current is very large. What about the output signal? The output signal will be in phase with input. So in common emitter, it will be reverse. So in phase in the sense, for example, if this is the input given, depending upon its gain value, if the gain is greater than 1, we may get a value magnitude wise larger, but it will be in phase with the input voltage. But whereas in common emitter, the phase will be reversed. For example, if like this you have given, you may get a output. You may get a output in out of phase. You may get output like this, right? Now here also, the in common collector also, the output signal will be in phase with the input. Now coming to the applications, for very high frequency applications, common base configuration will be useful for very high frequency applications. For audio frequency applications, common emitter mode, and for impedance matching applications, we will go for the common collector configuration. So this is what all about the comparison of common base, common emitter, and common collector configurations, right? But in exam point of view, these points are to be highlighted. We have to make the comparison with respect to the input resistance, output resistance, voltage gain, current gain, leakage current, and applications. Then it will be very easy for you to score more marks, right? Thank you.